So guys, welcome to our channel once again. In today's video, we have here these 7 questions to answer on the topic electric field. So guys, this video will be about shunt and multiplier. So in short, stay till the end of this video. Let's go ahead and start with the first question here. It says, a moving coil meter with an internal resistance of 100 ohms has a full-scale deflection when a current of 10 milliamps flow through it. What value of resistance would convert it to read 10 volts at full scale deflection? So guys, in order to convert this millicurrent meter, or let's say galvanometer, to a voltmeter, we are simply going to connect it to a series resistor, a resistor in series, actually a multiplier, which is a high value resistor in series. So guys, it means that the voltage across the system will be the sum of the voltages across the moving coil meter and that of the external resistor. So in that case, we are going to have that since V is equal to IR, so we'll have that the total voltage V is equal to IR for the moving coil meter plus the IR for the external resistance. So in that case, current here, which is the I, is 10 milliamps, which is 10 over 1000, and that's like 0.01. So in that case, the IR for the moving coil meter is 0.01 times 100 ohms. So that's plus the IR for the external resistance, and that's 0.01 times R. So let's say 0.01 R for R here. So all this is equal to the 10 volts. So 10 volts is equal to all this. So in that case, we can make R the subject of this equation, where R now becomes 9 over 0.01, and that's 900 ohms. So guys, the answer to this question is option B here. So let's go ahead and consider the next question, guys. So the question here says, a galvanometer of internal resistance 10 ohm has a full-scale deflection with a current of 10 milliamps. Calculate the magnitude of the resistance required to convert it to voltmeter capable of measuring up to 3 volts. So guys, here again, we are going to just employ the same formula. V here, which is 3 volts, is equal to IR for the galvanometer. That's I here for the galvanometer is 0.01 yet again. That's 10 milliamps is 0.01 amp. So times the resistance here, which is 10 ohms. So now this plus the IR for the external resistance here, which is the I is still 0.01 times R, which is unknown. So guys, in order to resolve this, R here is going to be actually the 3 volts minus the product of these 10 ohms and 0.01 amps, and that's like 0.1. So 3 volts minus 0.1, and all this over 0.01. So guys, that's 290 ohms, and that's option B here. So let's go ahead and consider the next question, guys. So that's question number 3 here. It says, which of the following factors will increase the sensitivity of a moving coil meter? We have A, strong spring, B. Small area of coil. C. Low number of turns. D. Soft iron core. So guys, the answer to this question is option D here, and that's soft iron core. So that's it for this question. Let's go ahead and consider the next question. So that's question number 4 here. It says, a galvanometer with a full-scale deflection of 20 milliamps is converted to read 8 volts by connecting 395 ohms resistor in series with it. Determine the internal resistance of the galvanometer. So guys, here we are just going to determine the internal resistance of the galvanometer. Well, we know that V is equal to IR, and then the voltage across here will be the sum of the voltages, that's IR for the galvanometer plus the IR for the external resistance. So in that case, the voltage given to us here is 8 volts. So 8 volts is equal to I, which is the current, and that's 20 milliamps, that's like 0.02 amps. So times the resistance of the galvanometer, that's 0.02 Rg, then plus the current times resistance of the external resistance. So that would be 0.02 times 395. So in that case, if we want to get Rg here, that's the resistance of the galvanometer, we are going to make it the subject of this equation. So in that case, we are going to have that 0.02 Rg is equal to 8 volts here, that's 8 here, minus 7.9, which is the product of 395 and 0.02. So guys, that will give us that 0.02 Rg is equal to 0.1. So in that case, Rg alone will be 0.1 over 0.02, and that's 5 ohms here, guys. So option C is the answer to this question. Let's go ahead and consider the next question, guys. So that's question number 5 here. It says, an ammeter can be adapted to measure potential difference by using A rheostat, B multiplier, C resistance box, D shunt. So guys, the answer to this question is option B, and that's multiplier. The multiplier is the high value resistance that is usually connected in series to an ammeter or a milliammeter, though in order to convert it to a voltmeter. So that's it for this question. Let's go ahead and consider the next question, guys. An ammeter with a full-scale deflection of 10 milliamps has internal resistance of 0.5 ohms. Calculate the resistance of the shunt required to adapt it to read up to 3 amps. So guys, we are going to solve this together. So guys, one thing to take note of first of all is that in a shunt, the connection is in parallel. So if we have a parallel connection here, it means that the voltage is the same across the system. So in that case, the voltage in the shunt is equal to the voltage in the galvanometer. So V shunt, that's Vs, is equal to Vg, that's V for galvanometer. So in that case, since we know that V is equal to IR, means that I shunt, R shunt is equal to I galvanometer, R galvanometer. So in that case, we also know that since this is a parallel connection, the current will be the sum of currents while the resistance will be fixed. So we are going to use this to determine the resistance here at each level here. So in that case, we are given the current in the galvanometer, which is 10 milliamps, and 10 milliamps is 0.01 amp. So in that case, for the galvanometer, we have I to be 0.01, and then the resistance for the galvanometer is actually 0.5 ohms. But then for the shunt, the current will be 3 amps minus 0.01 amps. So, and then the resistance is unknown, and that's what we are going to look for. So having that the current is 3 minus 0.01, so that will give us 2.99. So in that case, we have the current here, but we don't have the resistance. So IR for the galvanometer or ammeter is given, whereas, and it should also be equal to IR for the shunt. So in that case, the R for the shunt will now be IR for the galvanometer over the I for the shunt, which is 2.99. So that will give us 0.01 times 0.5 all over 2.99. So let's calculate this together. So guys, that's 1.7 times 10 to the power of negative 3, and that's here 0.0017. So that's option A here, guys. So let's go ahead and consider the next and last question. So that's question number 7 here. It says a galvanometer of internal resistance 50 ohm and full scale deflection of 20 milliamps is converted into a voltmeter by connecting a resistor of resistance 1950 ohms in series to it. Calculate the maximum voltage that can be read by the voltmeter. So guys, V is equal to IR, and V here is equal to sum of IR for the galvanometer and that of the resistance. So here, the resistance, the current here is given, which is 20 milliamps, and that's 0.02 amps. So we're just going to do 50 ohms times 0.02 amps, and that's for the galvanometer, then plus 1950 ohms times 0.02 amps, and that's for the external resistance. So let's go ahead and calculate this, and then let's see what we have. So guys, that's 40 volts here, and that's option D here. So that's the answer to this question. So this is where we'll end this video for today, guys. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below, and we'll ensure to give you a response. So finally, guys, we want to encourage you to join our YouTube channel community. You can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.